There's a lot of things that you need to do on the surface of another planet, such as exploring a site or maybe correcting an instrument or creating a temporary shelter to shield from dust or wind on Mars. We are looking into a swarm of soft robots that can move around the surface of another planet and then link together and create these temporary structures or do various tasks that we need them to do.
Right now, what we're focusing on is some different properties for these soft robots. We've been using silicone by 3D printing molds, pouring the molds, and then peeling out the silicone from there. And we've been able to make different pneumatic networks within the silicone so that when they're inflated, we have different types of actuation. So we're investigating these different properties so we can think about, okay, what would this look like on a lunar surface or a Martian surface? Some of the advantages for soft robotics are that they're very compliable, so you can twist, hammer, and then they still work. Soft robotics are good because they're compliable. They deform and can hold these objects better than a traditional robot, which is very rigid.
This is important because soft robots are extremely resilient to damage, and so they can be used for a lot of things. And if they're able to move around and create structures in different locations, they can create a structure, break down, and then move and create another temporary structure. So there's a lot of reusability factor with this.